Alrighty. Here's some unit conversions. So this is the relationship between radians and degrees. Um, this is kelvins to Celsius, right? So remember that Celsius is just arbitrary, right? It's how many degrees above the freezing point of water at one atmosphere, or something like that, right? Okay. So you got to add 273.15 to the Celsius to get kelvins, right? Okay, but be careful, right? A difference in if it goes from 130 kelvins, which is pretty cold, to 140 kelvins. How many degrees is that Celsius? Well, it's still 10 degrees Celsius. 10 degrees Celsius equals 10 kelvins. It's just a change of 10, right? Because kelvins is the actual temperature, right? And so anyway, we tend not to talk about degrees Kelvin. If we say kelvins, it's the actual temperature, right? When we can talk about changes in temperature, we tend to talk about degrees Celsius, like that. A light year is that many meters. That's how far light travels in a year, which is a parsec is that many light years. That's handy. An astronomical unit, that's the distance from the sun to the earth. Right, a kilowatt hour. Well, we could have figured that one out, right? A kilowatt is 1,000 watts, right? It's 1,000 joules per second times an hour is 3,600 seconds, right? There we go. Okay, now this one is actually very handy down here. Okay, you can use this. I wish they'd give us more sig figs, right? So the energy of a photon is h times the frequency, which is h c over lambda, right? So they're telling you hc, which is the numerator on this formula. Okay. So notice that you can do here, that's joule meters. Well, for the photoelectric effect, you're going to use this, right? So this is basically a quick and easy way to calculate the energy of a photon in electron volts, right? So if the, let's say you've got 430 nanometer light, right? The energy of that photon in electron volts is going to be 1.24 times 10 to the minus sixth electron volt meters, right? Divided by 430 times 10 to the minus ninth, because that's nano, right? Okay, and that'll give you the energy in electron volts, which is kind of cool. That's a handy thing. Although, the thing is, if you use the value of Planck's constant and the value of C, even in the data packet, you're off by a fair amount. I wish they'd give us more sig figs, but don't worry about it, because if they've got it in the data packet, you ought to be able to use it, right?